Hey Math Superstars, it's Dr. Conklin here to do a lesson review looking at inequalities and interval notation. So interval notation is a fancy smancy way to write inequalities. So there's a couple of key things to note. We have parentheses and brackets. So parentheses are curvy guys that look like this. Brackets are square. So one thing that's important to know is when we have open and closed holes. So on a graph, like if we look at number 1, for example, does everyone see here at 1 we have an open circle? Okay? So we're starting at 1, and when we go on forever in this direction, that is called infinity. And we use this little symbol here. I'll highlight it so you guys have it. Make sure to write, can't really see that, sorry guys. That infinity symbol means we go on forever in the positive direction. Okay? So we start at 1, we go on to infinity. Now, what do we put around these? Well, we're actually going to use these notations we just talked about, parentheses and brackets. If you have an open hold, I always remember if I put 2 like curvy brackets around, it looks like an open hold. Anytime you have an open hold, it means that the endpoint is not included. So like if we look at this graph here in example 1, 1 is not part of the answer because at 1 we have an open circle. Now let's say I had a number like 1.1. 1.1 we'd find right here on the number line. That would be included because it's really close to 1, but it's just a little bit bigger. So we're going to put an open, sort of the curvy bracket around the 1, and anytime you have an infinity sign, whether negative or positive, you're also going to have the curvy. And again, I sort of remember because if you look here, just a different color. If you look here on the infinity sign, do you see how that sort of looks like a curvy bracket too? Okay, let's try another. And I'm just going to sort of go down and do a few, and then we'll give you some to do for homework tonight. If I look at example 2, I see we're ending at 2. But if you look here, look down here. If I keep going left, 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 all these numbers are getting more and more negative. So this is not positive infinity, but negative infinity. So when I look at the interval notation, I'm going to say, well, I go to negative infinity, but I end at 2. And again, you need to do our little brackets. Anytime you have an infinity sign, remember it's going to be curvy. And then I have an open circle here, so that's also going to be curvy. Okay? Let's look at number 3. Same idea. I'm starting at 1, and I'm going on forever to the right. So that's positive infinity. So I'm going to write 1, positive infinity. Now, this is a little different. I have a closed circle. When we have a closed circle, we are going to use a bracket. You don't need to put it on there, but just so you guys can see it, closed means bracket. So I'm going to put a bracket in front of the 1. That means that 1 is an answer to the solution. So if I wanted to say, hey, anyone who has $1 or more can pay for pizza. Well, if I have $1, can I buy pizza? Heck yeah, because you have $1 or more. Now again, when we have these little curvies here, for the infinity sign, you want to make sure that your notation or symbol is a curvy too. Okay, let's look at, is it purple? We have a closed at 2, and if I look at it, I'm going back. If I keep following this along, I'm getting more negative infinity. So again, make sure negative infinity should always come first, and then 2, and then once I write my sort of numbers, right, negative infinity to 2, I'm going to put a curvy here, and then since this is filled in, the 2, I'm going to put a little square bracket there. The other way they can also ask us these questions is not if the numbers are going all the way to infinity, negative or positive, but just sort of what's happening. This interval here, or this set of numbers, like an answer to this would be like 1.1, 1.8, something in between 1 and 2. But 1 is not an answer, and neither is 2 because they have the open circles. So between 1 and 2, we have 2 answers, but they're both going to be the curvy brackets. Now look at this thing. Same idea, 1 to 2. this looks like the same answer, but what's different in our picture? We have a filled in 1, which means 1 could be an answer. So that's sort of like our pizza example. 2 is open, so that's going to be a circle bracket. And then if we look here, same idea, 1 to 2, but now 2 could be an answer and 1 could be an answer. Okay? This here, when you see how this whole guy is going both ways filled in? This is what we would call negative infinity to positive infinity, or all real numbers. Okay, so let's just look at page 5, just so you guys have a sense of how else we could ask these. So if we're asked to look at an inequality, the first thing we want to do is just review graphing it. I'm going to go to -8, and then reminder, let me put it right in the middle actually. -9, -7. So if I have greater than or equal to, or less than or equal to, I'm going to have a closed circle. If I have greater than or less than, we're going to have an open circle. So I'm going to start by going to -8. Since this has the equal to part on it, let me make it a little bigger. Right, this guy here is the equal to part. I'm going to fill this in. And then remember, this inequality, make it a little bit bigger, is almost like an arrow telling you which way to go. We're going to go to the right. Okay? Now, what does this look like in interval notation? Well, we're starting at -8 and we're going on forever, which means infinity. So let's put it in our notation, our brackets and curvies. Since this point is filled in, we're going to do a square bracket. And then a reminder, when you have infinity, it's going to be one of these. What is the smallest integer in this solution? The smallest integer, meaning what whole number is the smallest, is -8. The largest, well, if it goes on forever, it's going to be infinity. Okay, let's see. I did want to get down to some picture ones, so let's just pop down here to number 8, guys. And this graph is sort of not very accurate, so let me just put in -2 and 0. Okay, so if I look at this graph, it's first asking us, what does this mean as an inequality? This problem here, we're going to pick a variable, x is greater than or equal to -1. Now, why am I doing this equal to part? Because I have a filled in point at -1. So I'm starting at -1. I'm going on forever in the positive direction. Since this is filled in, I'm going to do a bracket here and a curvy here. Now again, what's the smallest integer we could have? Well, if we look here, what's the smallest number that makes this work? -1. And what's the largest? Positive infinity. Okay, last one we'll look at for today, number 9. So there's really a 9 here. I hope it's on your paper. So I'm going to just put 19 and 21. Okay, so I'm starting at 20, but I'm not getting bigger, I'm getting smaller. So we're going to do less than 20. Right, we're going in the negative direction. And we have an open circle. When we have an open, we know it's either greater than or less than. So when we're writing our interval notation, 20 is where we're going to get to the highest point, and it's an open circle. So I'm going to put my little swoop, right, my half open circle, but we're going to negative infinity. Okay, so what's the smallest number we could have? Well, negative infinity, right? Because this is going to keep going forever and ever, even when we get to 17, even get to 0, even get to -20, right? But the biggest number, be careful, the biggest number here is not going to be 20. 20 is not in this solution set. It's actually going to be one number before, which is 19. Okay, make sure you guys try our questions for today, and we will look forward to going over with these really soon. Bye, guys.